In a previous video, we started looking at some object-oriented concepts: encapsulation through the use of access modifiers, inheritance through the use of the extends keyword, and then we had a look at polymorphism. In this lesson, we're going to look at abstraction, the fourth concept which makes up object-oriented programming. But first, a quick recap of polymorphism. So having a look at this code here. So we've got a myChild object here, which is of the type myParentObject. This child is of the type parent. However, when we actually create the child, we use the myChildObject class. And we can do that because myChildObject here extends myParentObject. So we can do that. We can have the type be the parent object, but the actual object class be the child object. So we've done that in one case here. And what we're asking to do, the child to do, is simply to report in using the report function. So in myParentObject, we've got a report function here, and all it says is myParentObject standing by. Now we go to myChildObject. It's also got a report function. It's overriding the parent report function and just saying myChildObject1 standing by. So let's go back to our code. Just to recap, we create a myChild of the type of the parent, but the actual type is the child object. Then we ask the child to report. Okay, we're creating a second child, again with the type of the parent. However, when we actually create the object, we're using myChildObject2. So myChildObject2 also inherits from the myParentObject. Let's have a look at that. It's very similar to myChildObject. So it's exactly the same as myChildObject, except for we've got 2 in the class name and the constructor, and we've overridden the report function differently. So we're saying myChildObject2 standing by. So when we run this code, we can see polymorphism in action again. Just recapping, we've got both children, myChild and myChild2, are of the parent type. But the actual type is myChildObject and myChildObject2. And we're asking both children to report in. So let's just run that and see the output. Okay, just ignore the bottom line there. So we've got myChildObject1 standing by, myChildObject2 standing by. And that's an example of polymorphism in action. So onto abstraction now. We want to create a class that will simply add 2 integers for us. And the way we're doing it is we're using the object-oriented programming concept of abstraction. The way abstraction is handled in ActionScript is through the use of what they call an interface. So let's have a look at this line here. I've got my variable name, myMath, and then we have myMath there. Now normally that would be a class name, but in this case it's actually an interface, and we'll have a look at that interface shortly. Then we've got new, and instead of having new myMath, we've actually got new myMath implementation. Now this myMath implementation, it actually implements an interface. And what implementing an interface means is that you've actually filled in the required detail to make a function work that is defined in the interface. We'll have a look at those classes shortly. And all we're asking this myMath to do is simply to answer the question. So we've got another variable answer, which is an integer type. We're asking myMath to simply add 2 integers, and those 2 integers are 2 and 2. And of course, the answer traced out should be 4. Okay, let's have a look at the interface first. The MyMath interface. So it's not a class here, it's interface. MyMath. As you can see, MyMath is very simple. Instead of having here class, we've got interface, the keyword interface. And instead of having a whole list of functions, returning values, etc., we have our interface methods. And these, as you can see, they don't have a body. Normally, when you see functions, they have curly braces, like that. And they might, if they're void, they won't return a value. But in this case, we're asking for an int return type. So normally you would do something, you would like work out the answer, go num1 plus num2, and return the answer because we want an integer return type. But for interfaces, you don't do that. All an interface does is specify first the function name, which is going to be add two integers. It also specifies the parameters to the function, which will become arguments to the actual function, and also the return type. So we don't actually define fully our functions in an interface. We leave that detail out. And the reason for that is because we're using abstraction. So abstraction in object-oriented programming basically means we don't care about how this function performs its task. All we care about is that does its task according to our expectations. So our expectations simply are that this add two integers are going to take two numbers as arguments and return an integer. And that's all we care about. So that is abstraction. We don't care about how it's going to complete that task. All we care about is that we can pass two numbers and we're going to get back a number, which is the correct number. So that's all an interface does. It abstracts away the actual working or the steps to complete the function. It just defines what we expect to give it and what we expect to get out of it. So the input and the output. Okay, so that's our interface. Very simple, and all interfaces are generally very simple. That all they do is list the function signatures, they call them. Okay, so this is just what they call a signature. It doesn't have the implementation details or the body of the function. So let's have a look at MyMath implementation. MyMath implementation implements, and you see the keyword there, implements, MyMath. This class implements the MyMath interface. So all the functions in MyMath interface, they should be implemented or they should have a body in this class. So we've got the MyMath implementation, which is just our constructor there. And then we have add two integers. Okay, and we've got the parameters defined there. And we've also got the return type. But instead of having just a semicolon at the end there now, we've actually got the body of the function. And now this is a very simple case. We've got our function actually completing its task. So it simply adds two numbers and returns the sum of those. Hopefully you can see that we've got the signature of our function here. None of the implementation details. That's where we have to actually implement the MyMath interface to define how the function is going to operate in detail. And that's abstraction. Now in the case of adding two integers, obviously you don't see a reason for separating out the interface from the actual class that implements the interface. But with other functions, and certainly more complex functions, there will be cases when this is going to be very handy. And you're working at high levels of complexity, and you don't want to worry about how a particular function does its task. You might be getting code from some other developer, and you don't care how they wrote their function to, say, display a timer on the screen. You don't care about that. All you want to do, and all you want to use, is the interface to their code. And as long as the code completes the interface, fulfills the contract defined in the interface, we call it, then you're happy. You don't care about how it's actually completing its task. So that's abstraction in a nutshell. Let's run this, and we'll just go back to this one. So we've got our myMath variable defined as the myMath interface, not the class. And then we have new myMath implementation. So myMath implementation actually has all the code that fulfills the function. Then we've got our answer, which is just an integer type, and we run our code, myMath.add two integers, and we get our answer. I'm just running that again, and as you can see, answer equals 4.